In this session, we will show how to make the measurements of transmit EVM on your client device at rate. This uses the Golden AP, the RF card version, the RFA 36014, and WaveDevice to generate the traffic, but then uses WaveAnalyze in passive mode to look at the data that's being taken inside the wave blade itself on RF measurements. First step is to get the traffic flowing out of the client device. In a previous session, we showed how to connect up the system, configure the access point, and get a device showing in WaveDevice. That's already been done, and I've already set it up so that we're running 10 kilobits per second of traffic, very low level of traffic upstream. And this is now having this phone with Wi-Fi in it, a single spatial stream device, transmitting traffic continuously at 10 kilobits per second. Okay, once that's running, we can go open up WaveAnalyze, and we will connect to WaveAnalyze. First, we want to make sure that we're in passive monitor mode. That allows the RFA 36014 WaveBlade to be controlled by WaveDevice, and it allows the WaveAnalyze application to just pull the statistics out of the card and display them in this user interface here. So we'll take a look at WT-TGA0031, which is the chassis we have set up. We're going to connect up to it, and we'll find that port 3.1 is already in use. That's the one that we want to monitor the RF statistics on. So we'll reserve that. Since we're in passive mode, it doesn't take control of the port. It just pulls data from the port. Now, when we press the green button, we will see, and we're sending data at a very low rate. So you will see some of this flashiness here. But you can notice that our EVM is 3.3%, worst case maybe 3.8%. So we're seeing, and if we stop this and go back and take a look, that the constellation is not all that fantastic, but we are seeing 256, we're seeing MCS 8 frames, and we see that the EVM, it should be around 2.51 for this phone because we're talking MCS 8. And the best case and worst case are much beyond that. But the important thing you want to see on these client devices isn't what is happening when you are running very low data rates. What you want to see is what happens when you increase the data rate a bit. So we'll move to 10 megabits per second. All right, so still 10 megabits per second. We're running 15, 18 byte frames. Now we can go back, and in WaveAnalyze, we can see the performance of that client device when it is sending traffic continuously. So this is the industry's only full system test of a client device when it's running traffic. So here's the constellation that you see, and you can see that there are many points outside the spec. The spec is the green circle, and you can see all these points that are outside the green circle. Here from a measurement point of view, we see that the EVM worst case has gotten much worse once we begin running traffic at rate. This really matters because now when this client device is transmitting traffic to an access point, many of the frames coming out are at EVM that is far beyond spec, and this will result in FCS errors and retries having to be sent from the client device. So what we've just demonstrated here is the industry's only way to use your golden access point to set up known traffic out of your client device. Then, using that very same setup, go use WaveAnalyze to record and evaluate the performance of that product when it's running traffic. Everything about that product from an RF point of view should be meeting IEEE spec, even at rate. And we see clearly here that in the data subcarriers, it's not meeting. But now you get to see what the shape of the constellation is when running that traffic. The important thing to remember about WaveAnalyze is that the RF measurements are taken on every frame, not just the frames that can be captured as if you were using a vector signal analyzer, but on every frame. So you're seeing the true performance of every frame while running traffic, which is the only reasonable measure of RF performance of a transmitter of a client device.